Hello, Doctor. My name is Tahsin Ahmed, and I'm going to be introducing the project for our course this semester. So, our goal was to build a sumo robot that is capable of competing in a sumo robot competition. So, this sumo robot can be used in many real-life applications. Like, we can use this on the environment, like monitoring uh, different tasks. I mean, monitoring different tasks given to monitor. So, moving on, our project goal was to build a sumo robot, as I mentioned, to push the open robot out of a 100 by 100 centimeter square. And the control mechanisms, we used the communication module as HC05 Bluetooth module to control the sumo robot from our phones. So I was in charge of importing most of the components like the Arduino, the chassis, the ultrasonic sensors, and the Bluetooth module from a company called Seven Color Trade in China. Uh, we imported the stuff from China, the so we have a better chassis, better motors, and we can all get these stuff for a reasonable price than the local market in Dubai. And we had to buy a few of the components from the local market since we had issues burning. I mean, since we burned like some of our motor drivers. So we had to change our motor drivers and we bought from the local market as well. So that is for the imports of the components. So I was also in charge of making the FSM. So as you can see, this is the FSM, and I'm not gonna go deep into the FSM since we don't have time. I'm just gonna go through this. So stop, I'm gonna make all the motors go off. The front is gonna control the F command in the code, back for B command, left for L command, and the right for R command. And the follow mode is basically the ultrasonic sensor, which we couldn't implement in our project since we had lack of time. So I'm just gonna go through it. So autonomous mode via X checks the distance for the movement decisions and check it just reads the distance for the front, back, and stop. So that is it for my part, and thank you.
Hi, my name is Mohammed Asif, and I play the major role in the hardware of the circuit. And we use Arduino, as the brain of the our system. It was used to process the commands and sensor data to control the robot movements. And our motor system included four 12-volt DC motors and two BTS 7960 motor drivers. These motor drivers were used so that you can facilitate the peak current drawn from the four DC motors. Uh, uh, the 12-volt DC motors drew a peak current of 2.3 amperes, and the BTS 7960 drivers are capable of giving up to 43 amps. Uh, we we use the SC05 Bluetooth module to enable the wireless control through using a software. And we also use the SR for ultrasonic sensor to facilitate the distance measurement for autonomous mode. The Sumo robot's body was made from a GI sheet of 2.1.2 mm thickness. We made sure it was properly measured and designed using SketchUp so that it will perfectly fit the chassis that we bought. These are a few of the sketches that we made using SketchUp, and uh, the metal body was chosen for its strength and impact resistance, and we manual cutting and bending was needed to fit the chassis uh, to properly make the chassis, make the body so that it fits the chassis. We mounted the Arduino motors, sensors, and battery to the chassis, and it was protected using this body. The body was attached to the chassis using screws, nuts, and bolts, which was enough to keep the body intact. we made sure that there was enough contact between the chassis and the metal body so that it wouldn't shake or become loose, and it gave us a nice look for the Sumo robot.
Hello everyone, my name is Mukesh and I'll be now explaining the design process and the challenges we face while building our Simmer robot. We started by creating a final state machine to plan how the robot would behave. This helped us to decide how it should respond to Bluetooth commands in manual mode and how it should act on its own follower mode using the ultrasonic sensor. Once we had the logic ready, we moved on to setting up the hardware. We connected the Arduino, motors, sensors, and power supply, making sure everything was wired correctly and safely. Next, we worked on the Arduino code. The code listens for commands, processes sensor data, and controls the motors using the PWM signals. It follows the FSM we designed earlier, so the robot behaves exactly as we expected it to. While testing, we ran into several issues. Firstly, the L298N motor driver kept overheating and couldn't handle the motors. And we also gave the wrong voltage to the Arduino by mistake. To fix this, we switched to BTS7960 motor driver and used LM7805 voltage regulator for stable powers. Next, we also spent time calibrating the ultrasonic sensor so it could measure distance accurately and help the robot react in follow mode. But unfortunately, we had some minor problems before the match, so we could not activate or install the ultrasonic sensor in the battle itself. Now I'll explain the logic behind the Arduino code and its purpose. The main goal of this code was to give the robot both manual and autonomous control. It receives Bluetooth commands through its Bluetooth module from a phone and can also act on its own using the ultrasonic sensor. Now, we had manual control mode, where the robot responds to Bluetooth commands such as F, P, L, or S for direct movements from the user. Next, we have the autonomous mode, where we send uppercase and lowercase x to toggle on and off the autonomous follow mode in the robot. Now, the logic behind the autonomous mode was that when an object is too close to the robot, the ultrasonic sensor detects it and moves backwards, and when it's in a specified range, which is 20 to 45 centimeters, it follows it or moves forward. Next, this autonomous mode and manual mode both contributed to our small robot and made it a perfectly running system. Next, we have distance measurement and the motor control. This part of the code is for measuring distance using HCSR04 for ultrasonic sensor. It works by sending a quick pulse from the trigger pin and measuring how long it takes to bounce back to the echo pin. The time is then converted into distance in centimeters by dividing the time by 58. Next, we used this distance to decide how the robot should move in the follow mode, whether to go forward, back, or to stop. Now on the other side, we have the motor control speed using PWM. The analog ride function sets signals from 0 to 252 to adjust speed smoothly. Now we use 252 to be close to the maximum speed, but not the maximum, which is 255. Now this helps us to control the robot precisely and accurately.
This was the final setup of our Sumo robot. Uh, we tested this setup on the 1 meter square arena in our lab, simulating a Sumo robot environment. And we also tested the traction and the weight, the speed, and the power of the Sumo robot in the environment prior, so that we have an understanding of how the robot will perform in the competition. And we also tested the Bluetooth, made sure that there was no error or bugs in the code, so that uh, it responds as we wanted. And the match showed that the Sumo Robot competition showed that it worked exceptionally well, and uh, fortunately we fortunately won the competition. Thanks to your hard work and a lot of people, including Engineer Kasam, for troubleshooting, and my family members and my friends who supported us all the way through. And the footages of the competition will be attached at the end of this video. And yeah, thank you. Thank you so much.
Okay, you won. Good job. Okay, yalla, 3, 2, 1, start. Okay, you out.